Hi guys, in this video we are going to talk about the next subtopic of metric, which is determinants. Alright, what does determinants actually do? It is actually tools that later being used in calculating other things in metrics, such as calculation of inverse and so on. So in order for you to calculate for determinant, it is actually depending on the order of determinant. So if it is 2 by 2 or maybe later 3 by 3, the way to calculate it is a little bit straightforward. So let's look at that first, right? So assume that it is a 2 by 2 metric, 2 by 2 square metric. Okay, so the way to calculate it is by cross multiply and subtract it. Alright, so you have A11 times with A22 minus with A12 times with A21. So that is how you get the determinant, and the notation of determinant is this. So DET in square bracket A, or you can just put like a modulus, right? A, capital A. So let us try to look at the example. So we have this A and B. The one used to find the determinant, simply multiply 5 times 3 minus with 6 times 7. Right, this is like the solution here, and you'll get negative 27. As for B, 2 times negative 5, 4 times negative 3. So this is how you calculate it, and the answer is 2. This negative 27 and 2 is actually the value that will be used later in calculation of other things in matrix. Okay, now as for the third order determinants, right, as the order increase, the way to calculate it becomes a little bit complex. Okay, so for this one, as you can see, the way to calculate it by using the methods of this method. Okay, the way to calculate it is actually, first you need to expand the metric. That is the idea. So basically for 3 by 3 here, by default it have 3 columns. So we need to expand it into 5 columns by copying the first 2 columns and put it on the right hand side. Okay, and after that we just do it what we did before, like in 2 by 2 matrix, which is we multiply it, right? Multiply. So for the first for the first 3 here, we are going to sum all of them, and then after that we minus with the right hand side here. Right, so let's just try to do one, right? Okay, so if you look at this, okay, let us first expand it. Okay, so this is how we expand it. This is for the first example. Okay, so basically this is the original matrix. So we have 4 1 0 until row 3 here. Then we expand it by adding again another the first 2 columns. So 4 1 negative 9 3 negative 3 8, we put it again to the right hand side, make it 5 columns. So after that we'll just simply multiplying it. Multiply, so 4 times 3 times 1 plus 1, right? See, look, try to tally with this. 4 times 3 times 1, which is this one, plus with 1 times 4 times negative 3, this one, plus 0 negative 9, 0 times negative 9 times 8, this one, and then subtract with, right, the other diagonal part. So we have 0 3 negative 3 plus with 4 times 4 times 8 plus with 1 times negative 9 negative 1. So calculate it and you'll get this as the determinant for this one. The same goes for B. Try to do it. right? You just expand it by adding again row 1 and row 2 to the right hand side of this matrix and then conduct this operation. Okay, so that is for 3 by 3. So actually for 3 by 3 and above, there's another way to calculate it. First is by using this way, right? For 2 by 2 you already solve it. For 3 by 3 this is one way. The other way is by using minor and cofactor. Minor and cofactors is actually a method being used when you have higher order, right? So the way that we did until now, it is actually applicable to up until 3 by 3. So the next one will be minor and cofactor. This is the method that we're going to use in finding the determinant of higher order matrices. When I say higher order, it means that more than 3 by 3. Even so, 3 by 3 itself can also be solved by using minors and cofactors. Okay, so let's see on how to calculate minors and cofactors. So okay, if you look at this example, they are using 3 by 3 because, as I said, we can use 3 by 3 to calculate for it. Okay, so minor is one thing, cofactors is another thing. Okay, so let's see how to calculate minors for 3 by 3. So if let's say the question wants you to find minor for 1 1, so this is indicate the element, which element that you need to calculate the minor and the cofactor. So for minor 1 1 is actually at A11, so they want to find the minor for this one. So to look for minor for this one, okay, is by calculating the determinant of elements other than the elements within its row and columns. So basically, -2 here, A11 here is at the first row and the first column. So the way to calculate the minor for minor at this position is by calculating the determinant of elements other than first row and first column, which is this. So if you look at this, M11 is equal to the determinant of this value, -6, 5, 2, 0. So the way to calculate this, by simply cross multiply and subtract. So -6 times 0 minus with 5 times 2. So you'll get -10. Okay, that's how you calculate minor for M11. So let's try to do the second one, M23, which is M23. Okay, this is M23. Okay, 5 here. So basically, the way to the determinant that we need to calculate for this minor will be value -2, 0, -2, 2, -1, 2, right? This one. So remember, an element that actually not within the row and columns of that particular minor, which is this one. So we just simply find the determinant, -2, 2, -2 times 2 minus with 0 times -1. So sorry, it is actually here, right? For minor, this is cofactor. So -2, 2 times 0, -1, so you get -4. Okay, that is for minor. So basically, if let's say we want to look for minor for, let's say, M12, so basically the way to calculate for the minor is by excluding the first row and the second column, which will give us 1, 5, -1, 0. That's the idea. The same goes if let's say we want to look for M33 here. So basically, the value that we need to calculate is -2, 0, 1, -6. Okay, that is it. Okay, so the next one is to calculate the cofactor. So basically, to calculate the cofactor, we'll need to first calculate minor. So what happened in between, right? If you look at the formula, this is the formula. Okay, but I don't really want you to focus on the formula itself. Let's just find the idea. So basically what happened here is minor being calculated by calculating the determinant, right? The element, right, that is not within that particular minor, the element of that particular minor. As for cofactor, what happened is that by applying this formula later, you will see that you are just actually simply changing the positive and negative. Okay, let I show you what I mean. This is actually what really happened behind the scene for cofactor. So assume that we have calculate for minus. Alright, so for this one, M11 you will get -10, M23 you will get -4. So by applying cofactor, you'll see that this one become -10. As for this one, it become 4. The value itself is not changed. What's changed is actually what's possibly will change is actually the negative or positive. As for this one, you see it remain negative. As for this one, it changed from negative to positive. Why is that? So let's see. For cofactor, when we try to tabulate it in the array of matrix, you'll see that this is for 3 by 3, so that's why I put 3 by 3 here. This is how it looks like. For cofactor, it will always start with positive, and then negative, and then positive, and then negative again, positive, negative, positive, negative, positive. Right? So if it is 4 by 4, you can try to put it by yourself. It will become positive, negative, positive, negative, and then it will go on so on and so forth. So this is for 3 by 3. Okay, so the way to do it is by take the value of minor here, -10, times with this -10 times positive. So you'll get a positive value, a negative value, right? Sorry, negative times positive is negative. If you look at this one, -4 is at the position of 2, 3, which is 2 and 3. So here, so this is negative. So -4 times negative, you'll get positive, right? Or let's try to put it in the scope of this formula. So what I do now is I'm adding the value 1, just to make it consistent with the formula of cofactor. So as you can see, the way they calculate cofactor is by multiplying the the minor value of minor with this -1 I plus j. So for example, for M11, which is I is 1, j is 1, so 1 plus 1 is 2. So -1 to the power of 2 is positive 1. So positive 1. Let's say for the position of M12, so I is 1, j is 2. So 1 plus 2 is 3, -1 times to the power of 3, you'll get -1. Right? That is the idea. As for M13, M13 is equal to -1 to the power of 4. 1 plus 3 is 4, -1 to the power of 4 is equal to positive 1. And is actually, let's try to pick up randomly. So let's say we want to look for M32. So basically this is the area M32. So if we try to calculate for its cofactor, 32 is equal to 5. 3 plus 2 5. So -1 to the power of 5, you will get -1. See, it is actually -1. So this will later, when you multiply whether it's negative or positive later, will affect the minor. So